Hello student, this side Abrar sir again, and today we'll start ray diagrams for the mirrors, and we'll take the this is the phenomena why how and why we able to see the different objects in different types of mirror in different shapes. So here we just take the example of the images formed by concave mirrors. So in this section we will do the image formed by concave mirror. So very first example is when the object is at infinite distance. What is the meaning of infinite distance? The meaning of infinite distance is that we also see the stars and we can also see the images of the star in different types of mirror, and the stars are at very far distance. So how a concave mirror form a image while the object is at infinite distance? Okay, so just this is the concave mirror polished from outside, and as the principal axis, this point is a focus and this point is a curvature. So object is at infinite distance, so the light coming from the infinite distance is like this. The object is at infinite distance, so all the light will fall on the mirror, and after reflection, this is the light rays. After the reflection, the ray will come on the focus, and hence the image will be formed. The image of object at infinite distance will be formed at focus. Here the image will be formed this point, and the real image. Why the real image? Because this image is formed due to interaction of all the real rays which is coming from infinite distance. So all the real rays are interacting at this point, so the image will be formed will be real. The image will be point sized. The image will be of point size, very small. It will be point size, and the image will be inverted. Inverted means downward. Inverted means downward. That means if the object is like this way, the image will be downward. So this is called inverted, right? So here it is clear that when object is at infinite distance, the image is at focus. Mind these things which I am marking here. If it is at infinite distance, then the image will be at focus. The image will be at focus. Now we take the next category. The next category is when object is kept at focus. If we put the object at focus, then where the image will form. So very carefully, making these images is very easy. It's not a very difficult if you understand it in proper manner. Then these things will become very easy for you people. But you have to be very focused. Like this focus, and this is curvature. This is focus, this is curvature. In this case, we actually kept the object at this place. The object is at focus. We kept the object at focus. So the rays will like this, and any other ray will pass like this, and you can take many more rays to show this, but two are sufficient. We can also take like any image at this place, which is like this. So here you can see all three rays are parallel to the main ray, right? So parallel ray will never meet. Then where the image will form? The image will form, we believe that these rays may meet at infinite distance in space. So the image will be at infinity or at infinite distance. Right, students? The image will be at infinity. If the real rays will meet, we believing that, then the image will be also real image. And if it is real, it will also be inverted and highly magnified. So what you observed from these two images, the two figures, and I make them in a series because I can point out you, if the object is at focus, the image will be at infinity, highly magnified. But in the earlier case, you have seen when the distance was infinite, the image was at focus and point size. Here the phenomena is totally reverse. So when the object was at infinity, image was at focus. When object is at focus, the image is at infinity. In this case it was point size, here it is highly magnified. Now we'll take the third case. The third case is when object is kept beyond C. C, that means curvature. So in this case we're going to see the object is kept beyond curvature. So let's see how the image will be formed. So I'll just let me make it a little smaller so that you can see the image formation properly. It is F, it is C. So in this case we are putting the object somewhere beyond C. We are putting the object beyond C. So how its image will be formed? Let's see. The ray is coming parallel to the principal axis and passing through the focus somewhere, and we can take another ray which is coming from C. We can take another ray coming from C, right? So student, the image will be formed somewhere between F and C. The image will be formed at somewhere F and C. The image will be formed between F and C. So here you can say clearly this point is F and this is C. The image is somewhere here. The image is somewhere here between F and C. So this is image, right? So image will be between focus and curvature. Focus and curvature. The real image, inverted image, and smaller than object, size of object. These 4 points you need to understand. Okay, when you put the object beyond C, the image is between F and C, smaller than the object, Okay students, next we will make the image formation. Next will be next image we will form. Fourth, the object is kept between F and C. Now see the reverse. Earlier I kept the object beyond C. Now I'm keeping the object between F and C, because in earlier case the image was formed between F and C. Now I'm putting the object between F and C. So let's make it. So this is the mirror, principal axis F, it is C. Mind this distance, these two distances will be same, like this and this pole and the C distance will be same, so mind it. So we are putting the object between F and C. So we are putting the object between F and C. So okay, This is the object between F and C. Now the ray is going and coming back from the focus. Here it is. Right, students, any other ray which is coming from C, right, which is interacting here. This is any ray coming from C which is interacting at this place. You can see clearly. So in this case, the image will be formed beyond C. The image will be formed beyond C. What we are getting in this place? We are getting that image is between, image is beyond C. The image is beyond C. Real, inverted, magnified. In earlier case, we have image smaller than the object when the object was beyond C. Here the object is between F and C. Between F and C. So the image is forming beyond C. Beyond C. You can take another ray. You can take the ray will be certainly. Suppose that you in some books you can also see this kind of image formation. So I just make it also. So it will also be somewhere at this place, right, student? So because this angle and this angle will be equal, so you also get the same place, right? So this is the fourth. Now we will take another image formed. Now we putting the object is kept at C, curvature. Now we are putting the object at curvature. Right, students? So we are putting object at C. P F C. So we the object at C. Student, in this case the image will be also at C and of same size. So it is quite easy to make. The ray is going this way and like this way. Another ray is coming somewhere here. Striking like that. So and so in this case you can also see easily this point is your F and this point is your curvature, right, student? So in this case, when object was at C, the image will also at curvature. See, real, inverted and equal sized. In earlier case when the object was between F and C, the image was beyond C. The image was beyond C, magnified. In this case, the object at C, image will also at C equal sized. Okay student, we take one more example, and that is object kept between F and P. The object is kept between F and P. This is very important. Let's see how the image will be formed in this case. How the image will be formed in this case. Let's see. This is very interesting case. So this is P, this is F, C, say F dash, say C dash somewhere. So object is between, the object is in between the object is in between F and P. The object is in between F and P. So where its image will be formed. This is the only case in this case. So the light is and coming from focus as it is a mirror. Right students? So now where will we get the image? In this case, the image will be behind the you can see the virtual image of this object. You're seeing the virtual image of this object. So right students, so image will be behind the mirror. Erect, virtual and magnified. Right students, in this case you see the when object is between F and P, then the image will be behind the mirror. Erect, because this is the mirror, so light will not go behind the mirror, but we see the virtual image because light ray will come back this way. So the image will be virtual and erect. Right students? So in next class I'll tell you about some case of convex mirror and we'll talk about refraction phenomena. If you liked, if you understand, please share, subscribe my channel so that I can make more informative and intellectual video for you people. Take care. Bye bye.